Welcome back. Thank you for all of those online as well for you joining us. We never know what the time zone for you, so you're in the middle of the night. We're trying to make this conference the first really interesting, exciting conference that keeps you awake. And so it's always easy to forget people online when you are finally getting to meet face to face. I was talking with colleagues from the CIB 78 on how successful was the conference last year in Luxembourg, and most of them said the real success that was our first in-person conference in a while, and that was really worthwhile, the effort and all the kind of networking and post-conference experiences. So nevertheless, it is a really important thing for us to be aware that we're still kind of trying to grasp the idea of in-person, online, how to best connect, and for you here to be aware of who is online and find the people that actually can really make an impact or improve your own thinking. I mean, that's the whole point of the conference. The sessions, the paper sessions, I pretty, wrap up in 10-minute presentations, and there's, in some cases, there are a few for the hour that really limits, in my view, the time for discussions and debate or Q&A or opinion. So once again, please keep your questions for times like after the keynote. Tomorrow we allowed half an hour for debate and Q&A. So it's not just about that presenter, but the papers and the community that we are about. So I don't want to take more of the time for the after lunch session. We have our first presenter here, Anh Ly. Anh Ly, she's from Vietnam, so Hanoi or Ho Chi Minh City? Hanoi, but the paper is combined, right? Hanoi and Ho Chi Minh City, which is very exciting. Establishing collaboration model for BIM training program in technical and vocational education. That's excellent. Thank you, Lian.
Hello, good afternoon, everyone. Yes, my name is Anh Ly. I'm happy to be here to present our research paper with the title Establishing a Collaboration Model for BIM Training Program in Technical and Vocational Education and Training, a Vietnamese case study. First of all, let me introduce a little bit about our research team. I'm currently a postdoc in School of Built Environment in Massey University. Dr. Quan, the co-author, is a lecturer in School of Civil Engineering and Surveying in University of Portsmouth, UK. And before the employment in our current institution, we were both a lecturer in the Hanoi University of Civil Engineering. The other co-author are lecturer in the Ho Chi Minh City of Architecture and Construction College, which is the case study context of this research. So why we conducted this research? We all know that BIM has recognized as a platform for digital transformation for built environment, and both government, client, and IEC community in Vietnam were aware of the benefits of BIM in improvement the performance of the construction industry. So there are legal framework have been launched, increasing demand from client and the professional. They have they develop their skill to meet with the market requirement. However, as a developing country, we experience a lot of challenge in adopting BIM in the construction industry. So one of the main challenge is the lack of skilled BIM personnel. So the college in this study, they have established a collaboration model for training the BIM technician, which follow the actual requirement of the labor market. And the college, it is a vocational training for construction and architecture technician in Vietnam. So there are some qualification in the college, which including the architecture design, interior design, civil engineer, and real estate. And the targeted students for the college are the graduated from secondary and high school. So we freshly graduated from their secondary or high school which are in age between 15 to 18 years old. And they have the both institute-based training and on-the-job training curriculum. Regarding the BEAM training course, it started in 2012 and fully integrated into the curriculum in 2015. It is a 18-month program, which including 2-month BEAM-based project internship at the partner company. So the aim of the college industry collaboration training model is to provide students with a learning environment that they can expose the real life working environment for a BEAM modeler. This is a summary of the research design. So we started with a literature review to developing the conceptual framework for the college industry collaboration BEAM technician training model. And then with the consideration of the advice from the industry partner, we establishing the BEAM technician skill set. And finally, we identified the most in-demand skill for BEAM technician in Vietnam. So to develop the model, there are 3 questions. What are learning outcomes? What can each party contribute? And how to implement the collaboration to achieve the learning outcome? Apart from the literature review, the lecturer staff in the college has consulted with the industry partner to develop 6 learning outcome for the BEAM technician program. So as you can see on the screen, that from learning outcome number 1 to learning outcome number 6, we match with the different subjects. We try to offer students with different skills, such as understanding of the typical principle for engineering design, or understanding the fundamental knowledge for BEAM, or the understanding of the role and communication and collaboration for the BEAM implementation. And we with the from the beginning, the college has engaged with only 8 industry partners, but so far they got support from 20 industry partners, with mainly consultancy company and both domestic and foreigner company. So from the learning outcome, we got the advice from the industry partner to develop a model for the BEAM technician competency and the interrelationship among the competency. And you can see that it starts with the fundamental knowledge, which is in line with the learning outcome number 1, and the BEAM knowledge, technological competencies, and collaboration competency, and the self-development competency. So the detail of all the competency presented in the paper, it includes 18 competency. For example, for fundamental knowledge, it is the principle for designing, engineering designing. For BEAM knowledge, it including the BEAM concept, some standards, some BEAM standard, or the BEAM procedure, and so on. And every year, the college, they conducted an assessment survey with the industry partner to get their feedback about the student performance in the internship. And in 2020, the college did a survey with both graduate student and industry partner. So before doing the main survey, we did a pilot survey with the teaching team, and then we got response from the graduate student and industry partner. So the finding from the survey, we got that interestingly, the most 10 important competency are the self-development competency of students. So I can list it here that the SC1 is the attitude of students, the SC2 is the time management, SC3 is the flexible and open to change, and the CC1 is understanding the role and responsibility of BEAM technician in BEAM implementation. So we can see that top 4, top 5 mainly are the self-development competency and the collaboration and communication skills. So from the finding, we can see that the model, the collaboration training model, provides the benefit for all the partners. So for the student, they got the opportunity to expose the real life project during their studying, and they have experienced mentor at work. They have on-job training. They got the communication, information management, and some kind of workplace code of conduct skill, and so on. For the college, because most the TVET college, they have lack of resources for BIM training. So for college, they might have more resource from the support of the industry partners, such as software or infrastructure. And they also have the feedback from the industry partner for their program, and then they can update the program. And for the industry partner, they might have the chance to recruit the new staff, or they have the, improve their community image and also the community contribution. And we got some recommendation for future research. For example, we try to explore the interrelationship between the identified skill set in support the learning outcome of the student. So time up. Thank you for your attention.
Thank you, Anli. What we're going to do is have presentations go for the hour with the presentations, and if we have the time, we'll have the discussions at the end. And I reiterate what I said, the day after, we can also go back to the arguments around. I mean, this is a very real one. It's the two major Vietnamese universities adopting them, and we know what's the challenge with bringing people on board. So that really, going back to human capacity and digital transformation, that is the agenda internationally. How we deal with that is the challenge for all of us. So thank you once again. And we have our second presenter for the session. She is, I was just asking, yes, you. So are you still dealing with jet lag? And says, no, I'm from Melbourne Uni. I say, well, the tram lag, 5 minutes tram ride from up the road at Melbourne Uni. And the present, your name again? Sabindi Pereira. Sabindi Pereira is got a paper on unnamed, right? Unnamed aerial vehicles. And I was saying, what's the unnamed meaning about it is no people. So that, right, that means fully automated and controlled. So is this your one? Yeah, excellent. Excellent. Fantastic. So 10 minutes, and thank you once again.
Okay, so good afternoon, everyone. I'm Savindi Pereira. I'm a PhD researcher from University of Melbourne. And today I'm going to present my research on unmanned aerial vehicles for safety in the construction industry, a systematic literature review. Okay, so this is the outline of the presentation that I will be presenting today. So first I'll introduce you to my research, followed by the research method. Then I'll present the research findings, and then we'll discuss about the limitations and research opportunities arising out of the findings, and finally the conclusions and the recommendations. So a little bit about the introduction. So we all know that the construction industry is moving towards digitization and automation, and it has become possible with emerging technologies such as BIM, IoT, UAV, 3D printing, and so on. And on the other hand, construction industry is identified as one of the most dangerous industrial sectors, and therefore solutions and methods to avoid such risk-taking behavior is expected to improve safety within the construction environment. So among these emerging technologies, UAV, which is also known as drones, has a significant potential, specifically in safety monitoring and safety planning, because it provides another set of eyes to avoid risks within the construction environment. Sorry. Therefore, a systematic literature review to identify the applications of UAV within the safety space will provide valuable knowledge. And as a result, in this background, this research was aimed to provide an in-depth inquiry to bridge the gaps between research and practice in UAV for construction safety. Okay, so this is the research method that we adopted. This research followed PRISMA methods to document knowledge. And the keywords that were selected in this process belong to three categories. The first category was terms related to the technology itself. And the second category was terms related to the construction industry. And the third was terms related to occupational health and safety. So after we applied the exclusion and inclusion criteria, we came up with 103 papers. And after analyzing these papers, finally, this research included 33 articles. And this screening was done in April 2021. Okay, so this is the analysis of publications by year. And as you can see here, there's an upward trend in research in the application of UAV for construction safety. And we can see it's an emerging concept because the first most relevant article was published in 2012. And prior to 2016, much less attention has been given to this area. But after 2016, a slight increase can be seen. However, after 2018, a substantial increase is visible, leading to 14 publications in 2020. However, during the time this analysis was done, only 4 publications in 2021 was included. Therefore, majority of the publications in 2021 was not included in the study. Yet, after doing this paper, I went back to see how the trend was, and I found that even in 2021, this upward trend continued. Okay, so this shows that UAV for construction safety is an emerging area, but in future, more advancements and applications can be expected. Okay, so when the publications by the country is identified, we found publications in 17 countries. And the dark colors represent the countries with higher number of publications, while it fades as the number of publications decreases. USA had the highest number of publications with 39% of the publications, and Brazil and China were the next with 5 publications each. When the analysis by content is looked at, North America had the highest number of publications with USA leading in this sector. So looking at the map, we can see that while UAV for construction safety is more established in some parts of the world, it is a still emerging concept in the rest of the world. Okay, so we found these publications in 23 journal articles, and sensors and automation in construction were the most preferred avenues with 3 articles each. And these 6 journals only had 2 articles, while these 15 journals had only 1 article each. And also it was interesting to note that these articles were in 3 categories: the journals related to technology or innovation, then the journals related to construction industry, and the journals related to safety. And higher number of publications were found in journals related to technology and innovation. Okay. When the research methods adopted in these publications were concerned, experiments and prototype development were the most frequent research methods. So prototype development and program modeling and algorithm development were mainly to develop applications to improve construction safety through UAVs, while experiments were mainly to evaluate the effectiveness of these applications. Then case studies were mainly to explore the application, while questionnaire surveys were more focused on identifying the perception of UAVs for construction safety. So when the life cycle stage focused in this publication is considered, 78% of the publications focused on improving safety through UAV during the construction stage, where the majority focused on visualization and identification of hazards through inspection. Then maintenance was also another important sector, where mainly crack identification and structural health monitoring, focusing on crack identification, was the most prominent issue. And interestingly, we found one article that focused on hoist mapping and site layout planning to improve construction safety with the use of UAV. So we found that 40% of the publications did not specify the nature of the project in their research, which implies that the findings of this research can be applied to almost all the types of construction, while 36% of the publications focused only on the building sector. When it comes to the civil engineering projects, the majority of the research focused on bridge construction and how UAV can improve safety in those projects. So this shows the versatility of UAV in improving safety in the construction environment. Okay, so nearly half of the publication focused on hazard identification and visualization with the use of UAV, and safety assessment was also another area that were mainly focused. However, we identified that much less attention has been given to areas such as training and education, design for safety, and risk assessment and control. So these are some of the areas that needs future research. Okay, so moving on to limitations and the research opportunities arising out of these findings. These are the 4 areas that the research identified as limitation, but since I think I'm running out of time, I'm not going to go into detail, but I have elaborated these 4 areas in the paper. So these areas are sample size, technology integration, other safety conditions which can be focused, and also the limitations associated with research methods. Okay, so moving on to the conclusions. With emerging technology, construction safety can be improved, and UAV is one of the technologies that has a significant potential because it provides another set of eyes, especially in safety planning and monitoring. So this research, therefore, was conducted to investigate the current research status when it comes to UAV in the construction space. So this research identified an upward trend in the publications since 2018. So it implies that more attention has been given to this area. And we also found out that while certain areas were more focused, there are research gaps pertaining to other areas. And also another interesting finding we found is that while UAV alone can also improve construction safety, it was suggested that UAV can be complemented with other emerging technologies to maximize the potential. So that's about the presentation, and thank you so much for listening.
Thank you, Savindi. And once again, it's a reminder of all the things that are happening quite rapidly, but then you take the time to do the serious literature review that I forgot how painful could it be in a way. The legal side, did you look at it? Legal aspects of flying, licensing for yeah, but anyways, thank you once again. And our next presenter is, I understand, around here, which is also reassuring. And we saved your slides and tested everything. So
second row.
Here, yes. Yes. And Arthur Tomczak. Thank you once again. A review of methods to specify information requirements in digital construction projects.
Exactly. Thank you. Yes, my name is Artur Tomczak, and today I represent Norwegian University of Science and Technologies. And I will present to you a joint work on the review of methods to specify information requirements in digital construction projects. I will just take this one. So today we already heard about building information modeling. And when we talk about BIM, it's important to manage the information about buildings. And this presentation is not about what information we are requiring or what should we require on projects, but how are we doing this? So when I say information requirement, I mean the specification, what, when, how, and for whom information is to be produced. This is a methodology that we adopted in our research. So we started with analysis of use cases from the use case management system of Building Smart, as well as analysis of existing ISO and CEN standards. And we also did a literature review to see how literature covers existing standards. And then in the expert discussions, we tried to define the evaluation criteria for those methods and also to do the actual evaluation of those methods and comparison. Okay, here you can see a list of the methods that we have found, and 7 of them are standardized, and there are also some that are not standardized, such as, for example, very popular in the industry, text-based or spreadsheet documents that we often see on projects, as well as some proprietary and bespoke software solutions or open source scripts that allow to do similar tasks. And on the right-hand side, we tried to show the literature overlap, and we discovered that a lot of methods are not included in the existing literature. And if they are, there is very little overlap. So only 2 papers were describing as many as 3 methods at the same time, and none of them covered them in the top, focusing on the information requirements. Okay, to give you a better understanding of what I'm talking about, here's one of the examples. So in the Norwegian StatsBIC requirements, there is a requirement that says that all walls need information if they are load-bearing or not. So this is very simple to say with a sentence, but we have different ways to describe it in a digital software, in a digital solutions. So we can have it in a plain text explanation, we can have it as a table, or we can have it in a more advanced XML form, as you can see here. Okay, and here are the criteria that we have identified. I will try to describe quickly most of them. So first, we need to know to what elements the requirement applies to. So for example, a requirement could apply to all the columns at this floor. Then we can require how the information should be provided. So for example, what should be the data type of the information, what's the units of measure, some description, maybe a reference to a common definition. After we have this, we can also constrain the value. So for example, we can say that the number should be within a certain range, or that the value should follow a certain pattern. Next, we can also require for some elements to be present in the model, so that at least, for example, one element should exist, or that all of the elements that match the criteria should fulfill the requirement. We can also ask for some additional documents like drawings or schedules. We can also ask element to be within a certain model hierarchy structure. Some requirements also were interested in the geometry. So we identified 2 types of geometry. So how is the geometry represented and to what detail? Then many of the use cases, they also wanted to have some metadata. So those are used to provide the context of the information requirement. So for example, who should be responsible for doing this requirement? If so, for checking it, who should deliver this information and for what purpose and when? We have also found some other aspects that are important to evaluate the standards, such as the expressiveness. So what's the breadth of ideas that could be described with this requirement, dependency on shared semantic schemas or the technology that is available. And at the end, we have the governance, so which organization governs this method. And this is not easy to represent in a graphical form, but we tried to do so. Here you can see a table that shows the relative capabilities of most of the methods, not all of them, as some of the methods were difficult to evaluate because they come in different shapes and forms, such as the textual documents or proprietary software. And here you can see that most of the methods they allow to specify specify in what form should the information be provided. And we go into details in the paper if you're interested on certain differences between those methods. I must also say that it wasn't easy to evaluate all of the methods as they evolve as we speak. So some of the standards, they are still under development and they are prone to change in the near future. And to give you some interesting comparisons. So for example, all of the methods we found that are possible to be machine readable, so we can parse them, but not all of them we consider machine interpretable, so that the machine can check if the requirement is fulfilled. And those that we found best for machine validation are IDS and linked data. So you can see it represented with black dots. And we also found partial capability for such validation in MVD and data dictionaries. And for example, to ask for additional documents or drawings, we can only do this with IDM and level of information needs. If we are interested in geometry, we also have this capability in IDM and level of information needs, as well as in MVD and linked data. But linked data in this comparison is a bit unfair to compare because it is tightly linked to this certain type of data representation, which is a graph database. Okay, and when it comes to metadata, the best standards to give this context were IDM and level of information needs. And here are the other aspects that I have mentioned. So those we couldn't represent in a graphic form, so we decided to group those methods to categories. And I must also say that it's not that there is a better and worse category, because all of them, they have their own advantages. So for example, when we look at the expressiveness, the fact that textual documents are sort of free to express any ideas, it could be an advantage. It gives us more flexibility, but also it's more difficult to validate such requirements. So when we look at very strict standards such as MVD or IFC property templates, it's there's not many things that we can specify, but also you must be you can be curious why some of the methods they fall within into few categories. For example, MVD is both free and strict. And this is because when we analyze the use cases, we saw that even though certain technologies, they allow to be very specific about how the logic to validate requirement should be written, often people still use plain text explanation of requirements. So they don't often use the full capability of methodology. For example, when we talk about semantic dependency of the standards, some of the methods, they define meaning internally or they reference to other standards, and some of them, they rely on common industry schema such as IFC. And this also can be advantage or a burden. So for example, in the case that I was presenting with walls, having this requirement in MVD leaded to having a lot of similar requirements because each IFC version had to be defined in a different MVD file. Okay. To summarize, there are many standards for requiring information in building information modeling, and some of them overlap. And in general, they all have their intended purpose and should be chosen wisely, let's say. So for example, text documents are very common legal form to specify contractual requirements, and they are quite hard to automatically validate if they don't follow a certain structure. Data dictionaries and product data templates or data templates, they are best fit for specifying widely shared properties, for example, about products. And level of information need is more fit for project-specific requirements because it allows to integrate with contractual documents very well. IDM is very good for purpose-specific requirements, for example, for precast concrete manufacturers, how they should prepare the information and when this information should be implemented in the workflow. And for example, MVD allows to be, MVD is very good when it comes to validation, but its main purpose, it was intended to be for software certification. So it's very complex and hard to implement in the software. And IDS, so information delivery specification is a bit easier than MVD, and it's very good for validation of alphanumeric requirements, but it doesn't allow to validate anything about geometry, and it only can ask about properties from IFC schema. Non-standardized methods, they are very good when we want to be flexible with our requirements, and we want to be to adapt to project needs best. But since they are non-standardized, they are also less repetitive, so it's harder to have agreement with other companies as well. Okay, thank you very much for this. I recommend reading paper if you're interested in details about the comparison, but thank you.
And once again, we'll have questions after. So Alan, we have our last presenter for the morning, so don't run away. We stay here, Arthur. Thank you. It's been a great morning. First, you start with a big speech, and now closing. Yes.
Thank you very much. King, yes. Okay. Well, let's say that with reference to my presentation this morning, I will show you some specific part of the work, the way we have done it in the context of the Smart Build for EU project. Yes. So I'm happy to present. Oh, yes. Happy to present this on behalf of Sylvain Kubisky, one colleague in Luxembourg Institute of Science and Technology with Annie Guerrero and Clémentine Couja, who is working with us with ACTP in order to formalize a little bit this work in Smart Build for AU. Health, well-being and comfort in smart buildings, innovation. When referring to smart buildings, we have identified quite a set of different aspects to be considered. And we wanted to know, of course, for each of those aspects, where we are in terms of existing innovation and what is the state of play and what are the opportunity. One of the most difficult one has been probably with respect to those aspects of health, well-being and comfort. And I'm going to explain it very soon. This is the overview of the presentation. If we get first to the context and the state of the art, smartness in the construction sector, well, the context is once again related to the fact that we want to improve the smartness of our buildings in order to, well, be in a better position to solve these problems of improving energy consumption or energy efficiency housing stock. And in terms of needs, besides those specific aspects that moving from, for instance, passive isolated elements to smart grid-ready buildings, or buildings active as active nodes, I would say, in the grids, one of the key points that we wanted to tackle this is in which way the buildings are now answering occupant needs. In some way, we were used to probably erect buildings and then put people inside. Then probably we would like, at a given point in time, to consider people and then say how the buildings, not put people somewhere and then build the buildings, erect the buildings on top of them, but say, okay, considering these or those peoples, how are we going to have adaptive buildings that will fit better the occupant needs? And in particular, of course, in terms of comfort and safety. This is something which is also to be considered in Europe in a context which is very, very regulated by directives or initiatives from the European Commission. I'm not getting into the detail of all those ones, but one is very, very important, which is really the EPBD, which introduced this concept of smart readiness indicators. I presented quickly this morning. What we also, the context also demonstrate that there are already quite many technical barriers that have been tackled or are being tackled in various research and innovation projects. Still, we need more demonstration of innovative solutions, and we have also a slow market uptake and a wide-scale rollout of these solutions. So the targets overall of the context of this study, which is the Smart Build for EU project, is in some way summarized here. But one aspect is really to better keep take into account, I would say, the needs and the engagement of building occupants in particular. So, as I already introduced to you, we have done a full approach in Smart Build for EU, trying to consolidate the smart building innovation community, which is the base to then, of course, address the different problems and have stakeholders working together on those different problems, knowledge sharing and supporting activities for the smart building innovation community, support to stakeholders for the promotion of the SRI, the research and innovation roadmap, and an enhanced visibility for the smart building innovation community. So this is mainly for, of course, the Smart Build for EU project. If we go now for one specific topic, which is the core, I would say, of this presentation and paper, this was really about how are we going to consider that smart buildings are dealing with health, well-being, and comfort, considering that some definitions shows that, well, a good indoor environment equally relies on those three concepts of health, well-being, and comfort. We have done some studies in terms of what are the different characteristics, what are the different elements that really typify, I would say, the notion of health, well-being, and confirm, and in particular, well-being in buildings. And you can see that, of course, there are quite different considerations in terms of, for instance, as far as health is concerned, there is mental health and physical health as well. In terms of well-being, there is, of course, the environmental quality, the satisfaction, and the overall comfort. So there was probably a need to get first to an agreement of what exactly are we going to consider in terms of health, well-being, and comfort. Another point is that there are indeed already private certification schemes dealing with those aspects. You probably, all of you probably know LEED and BREEAM, which are already considering some specific aspects, sometimes regarding health or comfort. We also identify other ones, just like, for instance, the WELL certification scheme developed by the International Well-Being Institute, or the FitWell. So all those are indeed also trying to target, but sometimes in different way, those aspects of health, well-being, and comfort. There is also a more, I would say, European specific certification, or let's say rather evaluation framework. It's not a specification, sorry for that. It's really an EU evaluation framework for buildings overall. But in this framework, there is indeed one specific section, if I may say, which really deal with healthy and comfortable spaces, concentrating on indoor air quality, on time outside the thermal range, on lighting and visual comfort, and on acoustics and protection against noise. But overall, I would say that smart services are not so much covered per se. So this is something that has led to the following research questions for us. Before indeed trying to identify what would be a potential roadmap for future smart buildings relating to health, comfort, and well-being. Beyond the existing standards, can we agree on the definition of comfort, health, and well-being? And we wanted to try to see if we can get to this common understanding and common definition, at least throughout all European stakeholders. What are then, the second question, what are the specific parameters, methods, and means enabling user-centric building? And what specific parameters are indeed attached to enhance well-being, inclusiveness, and health? And the third question was how to deal with potential heterogeneity of users across generations, countries or regions, and this is particularly typical in Europe, of course, genders, socioeconomics, and so forth. So depending on the question on those, depending on the answers to those questions, then we will go for a potential roadmap for future development. So what we have done, once again, there was some literature review. There was also a work which has been done with focus group, once again, in the context, of course, of the Smart Build for EU project. So I have to run, I guess. So very, very quickly, to do this literature review, we have done a query, a simple query on Scopus, on the Scopus database, to retrieve overall 130 plus publication with a keyword analysis, either through the index keyword and the author's keywords, which already exhibit the most important keywords that have been popping up, but also show differences between the index keyword and the author's keyword. So that was an interesting point of view. The research addressing both energy and comfort in general focus on personalized energy system. So mainly, well, all those aspects which really relate to, for instance, HVAC optimization or visual discomfort, thermal comfort, or indoor air quality sensor device, for instance. Or if we consider both energy and comfort, well, some kind of personalized comfort, ventilation, conditioning, lighting, and so on and so forth. With respect to the focus group, what we have done is that we have structured brainstorming sessions with overall 46 AU professionals. So you can see the various types of professionals through 4 online sessions. The first one was really to kick off the idea and to define really the overall framework of what we wanted to achieve. The online workshop focused on scoping the concept, workshop on barriers and drivers, and final workshop on the gaps and opportunities. Then, based on this, the intention is, of course, to derive some kind of roadmap. Okay. And we have a collection of ideas and votes. We have used in some ways some virtualization of the concept of meta planning through the concept board software tools. So roughly in terms of finding of these brainstormings, well, the scope has been confirmed that there is indeed a rich variety of definition and point of view, and this is still something that have to be carefully studied. That technology progress is visible, and we have already identified quite a lot of those technology progress. Barriers have been elicited in terms of technical barriers, economic issues, social acceptance, value chain, and regulation. So we have to deal with those 5 types of barriers. and opportunities have been really identified from a construction informatic perspective, in particular with those aspects of data-related methods and AI, interfaces enabling a building to interact with the occupants, sensing of building conditions, and the overall data management. So as a conclusion, very, very quickly, some answer to the research question. Literature defines comfort, health, and well-being, but still there is a significant difference remaining. So we need still to keep on refining a common definition of those aspects. For RQ, for research question 2, what are the specific parameters? The literature review informs on the specific parameters, methods and means enabling the interaction with users, but most scientific papers focus indeed on comfort, while health and well-being seem to be more a concern for the commercial certifications. And there are still some clear social barriers in the understanding of the parameters. And for the last question, well, there is a highly subjective perception of comfort and well-being. And though in theory, the smart system that we have to define will have to deal with this heterogeneity of users, but this means that we really have to develop a deep research on that. So what I mentioned to you at the final conclusion, the outcomes of this task force are expected to be turned into recommendation for future research and innovation program, in particular to the European Commission to launch specific calls on this hot topic. Thank you very much, and sorry for having delayed a bit.
Alan, thank you. When you say you, I was just trying to save your voice from totally. Should we have 1 or 2 questions? It would be really good to wrap up, even if we are running. We have a plenary session starting at 2, and then there is a lunch break, and then we're back here at 3:30. I'm correct? So we're back to the CIB 78 at 3:30. The other thing that I'd like to mention now is that even for the sessions that are only online, excuse me, I'll be here. So for the online sessions, I'll be here in the room. So if you want to join for the online sessions in person, that'll be great. And just revise the program, but pretty much the only changes we'll be making is if a presenter wants to, present earlier within the session or later, but we're not moving across days or anything. So the program that you've seen, we hope it stays as it is, but might be within the session that we just reshuffle a little bit. So a question or 2, please, for any of the morning presenters. And tomorrow after the keynote from Nora in the morning, we'll have 30 minutes for discussion as well. So write down today's incredible sessions that we had, starting with Alan as the keynote. But a question or 2 before we stop the session, conclude the session. Is yes, Alan.
Yes, maybe a short question to the previous presenter. So thank you very much. That was very, very interesting indeed, and very, very comprehensive. So far, I would say, but probably you still plan, of course, to dive into more detail of it. But well, there is clear outcome that there are different ways to define these information requirements, and each of them have some advantages. Well, there are some pros and cons for all of them. So at a given point in time, what is your views on how to process with the selection of one methodology rather than other one? Is it something that you have already think about? Maybe not, but if you have done it, or do you plan to do it? Do you foresee any ways of at least guiding, depending on maybe on the type of project, depending on the type of information, depending on the type of information requirement, the way that we can find the best path in some way using the most appropriate methods, well, standards or non-standards.
Thank you very much. Very good question. And yes, so as you said, they seem to be overlapping to great extent, but in fact, I should have said that at the beginning. Some of the methods that I was covering, they are not made just for information requirements. Some of them, they have a bigger scope. And I only looked at this tiny part of some of them. And I think there is a space for having many standards. And this paper, I hope, will suggest to the standardization body a way to harmonize the standards and maybe either integrate them better or even differentiate so that there is less overlap, but more clarity and transparency, because people, as we could see in the use cases, they're often confused and they use the wrong one because it's probably maybe more popular than the other, but it's not fit for their purpose. So I think, yeah, I hope I answered your question. I see there is one more. I don't know if it's for me.
Thank you. Of what I understood is we have in the next 19,650, you have the exchange information requirements. Once it becomes digitalized, you speak about information delivery specifications. And then all the other ones are building blocks, I guess. So if we go to the level of information need, we will need the data dictionaries and the GUIDs, which are defined by all these technical committees. So I thought they were all building blocks trying to make something which in the future will give some kind of automated, digitalized IDS, and not as being separate systems. They're linked together, I thought. So I don't know, what is your point of view?
I agree. They are sort of all fit in this environment and this ecosystem, and they are often linked to each other, but in a way they also overlap. And I think as long as we choose the right tool for the right purpose, I think we need those standards. And this was also not easy to evaluate and compare those standards. That's why we tried to have a quite representative group. So among the co-authors, I was maybe the neutral one, but we had somebody representing more ISO standards, somebody more Sense standards, and one person representing Building Smart, and the last one representing like open source community. So we tried to, to see what's the interaction between those methods and why there are so many of them. And I think, I hope the paper answers why we have so many of them.
Okay, Arthur Tomasek, so please follow up with him.
Thank you.
He just opened up a Pandora box with all the standards. Harmonizing them will take a few years, but that's why we are here, right? And thanks once again for a very interesting session for all the speakers today. I think, and I said that one more online question. There you go. Let's just fit that in and then we close so they don't feel cut off. Our friends online, what is it? So I'll read it. Question for presenter 3, so also for Arthur. Can you comment on the differences in effort for defining requirements within the methods presented, where you are able to capture data on that aspect?
Sorry, I need to read it again, sir.
Yes. So can you comment on the
differences in effort in order to make the requirements?
Input, yes.
I think the plain text method to describe is the easiest one. We don't need to learn much. We can just write in text what we want. And then some of them are easier. The tabular ones are easier because we see a column and we should know like what to put in this column. But when we go to those that are based on XML and XSD syntax, it's a bit more advanced, but luckily there are some tools that implement those standards that make it easier. And I don't know if the question is about implementation in a software or like implementation on a project. So it's difficult to answer completely, but
absolutely, it's an open-ended question.
Yes.
And we're not trying to validate the question. So our friends online as well, please follow up with Tom. So thank you so much, and thank you for the presenters this morning, and once again for Alan. Thanks. We'll be back here at 3:30. That's our afternoon session, and I have a nice break, lunch break, and talk a lot. Thanks.